Why, hello, welcome to our lesson for today. Now, in continuation from last week's acids and bases lab that was focused upon if you dropped particular solutions on the floor of your home, or like if they get caught in a carpet, what is the particular methods of cleaning them up? It's very important for you to know whether it's an acid or a base, and this is going to be the reason why. When acids and bases come together, it forms a chemical reaction called a neutralization reaction. So when an acid and a base are joined together, they attempt to neutralize out the solution. So for instance, let me give you an example. If you had a solution that was a pH of 12, so a base, and something that was a pH of 2, that was an acid, what do you think the pH of the final solution would be? Now, we are going to go over some examples of this and the methods of how to calculate it. Now, one thing I will tell you is that, as a fun fact, the two things that always show up when you do this and add an acid or a base together is you will always get oxygen and hydrogen coming together to form water. Remember, acids have hydrogen ions and bases have OH or hydroxide ions. Well, if you add H to OH, you have two H's and one O, also known as H2O. So you will always get water being formed, and you will get something called an ionic salt, a salt that's in there, not necessarily NaCl. Ionic salt is a chemistry term. All right, time to get into the two examples. So here's two methods that I'm going to share with you, and I really don't care which of these two methods you decide to use, but I would write them down, or the examples that I'm going to do on my little whiteboard here shortly. All right, first of all, option number one is using zero math functions. You don't actually have to do any algebra in order to do the first method. So here's the first method. Let's say it's the example that I had from the last slide. pH of 2 added to a pH of 12. So you list the lowest number, 2. Okay. Then you list all of the numbers going up until you hit the highest number. So I just list them just like this, from 2 to 12. Now, the last thing you do is just find the middle. So here's the way that the middle is going to work. And I'm going to go to full screen on this one. Stop share. There we go. Hello. Now, so go right ahead and we will cross off the 2, cross off the 12, cross off the 3, cross off the 11, 4, 10, 5, 7, 9, 6, 8, and look at that, you are left with 7 as your middle number. So 7 is going to be the pH of the solution. That's the way that a neutralization reaction works. Now, there is a particular issue with this, and let's say instead of just 2 to 12, we change it slightly and it goes 2 to 13. So you have 2, 3, 4, 5, 6, 7, 8, 10, 11, 12, and 13. So when you cross these out, so crossing out 2 and 13, 3 and 12, 4 and 11, 5 and 10, 6 and 9, and there you go, now we're stuck. You're stuck there between 7 and 8 because you can't necessarily cross them both out, but there's a little teeny bit of math involved. So the answer here would be 7.5 is the pH. 7.5. Now, little bit of math involved in that one if it ends up being a non-even distribution. Now, the other method is a mathematical one, and it's called mean neutralization, not mean meaning angry, but the mathematical term for to calculate an average is called to calculate a mean. So a mean neutralization. Now the method here is going to be that you are going to add the two numbers together. So in the same exact one that we just had, you are going to add 2 and 12 together, and then you just divide them by the number of solutions. So this method also works for if you have more than 2 solutions being poured together, as long as they're both acids and bases. You could do this with more than one solution. So taking a look at this one, the same problem we had looks like this. A pH of 2 plus a pH of 12 equals 14. We then divide 14 by the number of solutions, 1, 2, divide by 2. So the pH of this solution is 7. Now that was the same exact answer that we got on the other one. Now, the second example that we had was 2 and 13. Same thing happens. You have 15, you add them together, divide them by 2, and you would get 7.5. So both solutions do get you to that same exact thing, but that second one mathematically could be easier for some people, and then maybe the first one if you don't want to do the mathematical functions. Now, the neat one about the second method is the fact that if you had more than one added to another one. So let's say we had a 2, an 11, and a 12. And now this only works if they're all in the same exact amounts, like 50 milliliters, 50 milliliters, and 50 milliliters. Now, if you add all of these up together, you would get, let's see, carry the 1, 25. And then you would divide 25 by, there's 1, 2, and 3 different things together here. So you would divide it by 3. And we'd get just over about 8. I think it's like an 8 and 1/3, so 3 repeating. So just about 8. Now, that would be the way that the mean or calculating an average works for neutralization. So if you technically had exactly the same amount of molecules of an acid and a base, and let's say it's crazy dangerous could kill you, crazy dangerous could kill you. If you pour them exactly to the molecules together and it neutralized to 7, it would technically be safe to drink then. Now, I'm not going to risk that because all it takes is a couple atoms being different for it to cause some serious harm in my body to not fully mix together. All right, so that's how neutralizations work. Now, let's talk about our last concept, and that is digestion in the body. Now, digestion happens in 2 ways. The first one is called mechanical digestion, and that's just a really fancy way of saying chewing. Mechanical digestion, mechanical means physical. So if you had a piece of bread and you bite it, you're just breaking it down into smaller pieces. You're not actually breaking it down into its chemicals. However, in the mouth, you have chemicals that are enzymes called pepsins and things like that. And chemical digestion does actually break it down into its chemicals, its molecules for your body to actually use. Now, the human body breaks it down food in 3 different places. The first one being your saliva. Now, I know it's kind of crazy to think that human beings, your saliva isn't just water. It is actually a chemical. It is neutral with a pH of 7, but it does have enzymes in it that start decomposing food quicker. There's a particular candy called M&Ms that always say melt in your hand or melt in your mouth, not in your hands. The idea there is that even if it's warm in your hand, it's not necessarily supposed to melt until it hits the enzymes of your saliva. I know, and so do any of you that have held on to an M&M long enough, that they still do melt and color your hand with that candy coating color. Now, the second place that it comes into contact is your stomach acid. Stomach acid is a pH of about 1.5 and 2, depending upon how acidic your stomach currently is. Some people do have naturally more acidic stomachs. And if you do, you have a tendency to probably get heartburn or stomach aches a little more often. Maybe you have to utilize some antacids like Tums or some of those things that we talked about in the acids and base lab, like Alka-Seltzer tablets, to help neutralize out your stomach. So in your stomach, that is going to do most of your decomposition of the food. However, it doesn't just finish in your stomach. It does continue through your small intestines, your big intestines, and in your small intestines. Now, in your small intestines, you have a thing that is released, a solution that's released from your pancreas called bile. Now, bile has a pH of 8, and it's meant to be slightly basic. And this is kind of for a little bit of a gross reason, but you know what? It's your body and it's how your body works. The reason for that is if the food comes out of your stomach and in your intestines, and it's still coated with a little bit of that stomach acid as it's breaking it down, this would actually cause quite a lot of distress to your colon when you poo out this particular food. Now, the bile coats the inside of your small intestine and it helps to neutralize out, in a neutralization reaction, neutralize out any of the particular acid that is still on that remaining food remnants so that when it comes out your body, it doesn't harm your particular skin because it is as close to neutral as possible. So there's our particular ways as of how your body breaks it down, both physically and the 3 different ways chemically. So this ends our notes for this particular unit. I am wondering from you, when you combine an acid and base together, what particularly happens? We are moving into our unit review through the rest of the week. Adios, amoebas. Have a fantastic rest of your day.